How are things going, everyone? Today what we're going to talk about is recursive functions. So basically there are many cases where we need to use recursive function depending on the property of the problem. But today we want to in particular, particularly take a look at how we can understand the concept of a recursive function depending on the situation. So let's see. It says design a recursive function returning the reverse layout of the function. I mean the reverse, I would say, configuration of the given string. So let's keep thinking about how we solve this question. So what I want to do is basically reverse function. I want to define a reverse function as a string. So let's think about it. Like if the string is ABC, what we want to return ended up is we want to return CBA in a reverse order. So the way I can do it is recursive call. So basically, in order for us to think about recursion, we all the time need base case, meaning that we need the very last moment, and it should return something so that it can traverse back to our original point, and it can or combine the data, even though it happens maybe less than a few seconds, but in the behind of the computer, that's how the system works to cache those temporary functions, basically calling itself. That's what recursion means, and it can reach out to the further status. So the reason why we can think of recursion in this case is there needs to be some certain repetitive commonality going on. So if you figure out, okay, so we are going through the same pattern of the steps by over time, that's what we want. That's the point where we want recursion. So if we say, if we want to stick them up, so if we start with, hey, I want to start with the C and I want to like append the B to a C, I want to append A to a previous string, that's where the recursion kicks in. So let's think about the base case. So if, what I'm saying is if that length of a string is equal to 0, this means, okay, I'm gonna somehow manipulate my current state of a string. I'm gonna keep probably decreasing the number of strings. And if that strings, so what I'm saying is, this is how I'm gonna take a look at it. This string's basically gonna be given as a temp variable, and then reverse other string variable. So this is how I want to look at it. So basically, if the first temp, I wanted like temp equals actually basically string 0. The first I want to define a temp variable as the first character of the string, and I want to reverse the rest part of the strings in a reverse order. And I keep doing this pattern repeatedly. And if the length of string eventually, because we're going to keep decreasing the number of strings here, is if the length of strings, reaches 0, this means if I get to a point where there's no strings behind a certain string, what I want to do is just return none or return empty string. Otherwise, what I want to do is I want to, like I said, temp variable is string 0, meaning that I want to take care of a first element, and then I want to reverse the following coming after. So I want to reverse function calling itself in string, I'll say 1 to the end. Okay, so what it basically does for the first step is, okay, first, as you know, the temp is what? A, and reverse, what I want to do is BC the strings coming after. Next time the loop is gonna be temp is gonna be B. This one's gonna be I want to reverse actually C, because that's how this Python, the slicing or indexing is working. Later on, okay, now I temp, because I set it as the first element was C. Now I want to reverse empty string. And as you see here, hey, if I want to reverse empty string here, it's going to return nothing. So this is going to return nothing. What is this going to return? See, reverse, this returns, this going to return previous, all the accumulations. So basically this function, we need to like print something and see what's going on basically. So we can add, hey, I want to print at that kind of, I want a temp variable at that current step. So I want to print the temp variable of this one. In this case, temp variable C is going to be C. next time when it reaches this one, okay, this time I want to print the temp variable of B, temp variable A. So what I'm saying is we can try test it, A, B, C. So see, as you see here, why is it printed CBA? Because this C basically is printing off of this reverse. So if C is this one, then temp is C, and we want to call this function at this time, which is this one. This is returning anything, because this is called the base case, right? So that we can kind of pop back off, because this base case is returning nothing. I want to say, okay, this at this time temp is C, and I want to print of C, and then why is this one is printing B? We need to keep thinking about it. This function is basically printing off this part, which is it would have happened earlier than this one, which is temp, and this is functioning is returning somehow this one, but this is not returning any. I just maybe you're returning none, so it's returning B and C. So what I want to do is I want to like print out and equal probably this one in Python, so that it will be like CBA. Okay, what about A, B, C, D, E, F? We are expecting F, D, E, C, B, A, right? F, D, E, C, B, A. Cool. What about, if I were to say apple, then I want to say ELPPA, something like that. So this is sort of, so it's hard to think about. It's definitely not an easy concept, but it's very useful in real industry. Once you can't think of something, you need to probably break down each step by step, and then keep breaking down the problem into where we reach to the point where we reach our base case. We can still like pop back up and see, okay, so this is base case returning nothing. What about this? What is going to return, or what is going to print it? Okay, this we can print it C, we can print it B, so it keeps going back on. So I hope you enjoyed my video, and I hope you have better understanding of what a recursive function is. Thank you.